Congratulations, you've made it to the final lesson of this course. The Pythagorean theorem is a special formula used to calculate the missing side of any right triangle. A right triangle is with one angle that is equal to 90 degrees, which appears to make an L. The 90-degree angle is often identified or marked with a small square in the corner of the angle. The side of a right triangle directly across from this angle is called the hypotenuse. So this side right here is called the hypotenuse. It is the only side on the triangle that will be at a diagonal. The other two sides are called legs. These are the straight sides here and here. We often label the legs with an A or a B. A stands for altitude and B stands for base. But depending on the way the triangle is turned, it does not matter which leg you label A and which you label B. But side C is always reserved for the hypotenuse. The formula used to compare the lengths of these three sides is called the Pythagorean theorem. I'm going to write out the Pythagorean theorem here. A squared plus B squared equals C squared. This formula will appear on many formula sheets that you will see whenever you take a standardized exam. So you never have to memorize this formula as is. But unfortunately, the formula as you see it does not have any one of those three variables all by itself. So it doesn't really solve the missing side the way it currently looks. You do have to rearrange this formula to solve for any of the three variables that you're looking for or that you're trying to calculate. So let's rearrange this formula to solve for each of the three variables. Let's start off with side C. Because C is almost already by itself, we see that here is the term with the C in it, and then we have an A term and a B term. Well, to get C all by itself, you notice that it has the exponent of 2. To get rid of that exponent, you have to do the opposite of an exponent, which is a root. So if we take the square root of both sides, that will cancel out that exponent of 2. So you're left with C is equal to the square root of A squared plus B squared. Now this is a formula we can actually use. With C being all by itself, you can use this formula whenever you do not know the length of the hypotenuse. Now it's a little bit more tricky with the two legs. Let's try to get our A term this time all by itself. So the other terms we see in the formula are the B term and the C term. Because the B term is being added to our A squared term, to get rid of it or move it to the other side of the equation, we would have to subtract the B squared term. So that would cancel out, and you would be left with just A squared is equal to. Now C squared and B squared are not like terms. So all you can do is write C squared minus B squared, like this. Our A term is still not all by itself. We see that there's an exponent of 2 on there. So to get rid of the exponent of 2, you'd have to take the square root of both sides, because the opposite of an exponent is a root. And that would leave us with the final formula of A is equal to the square root of C squared minus B squared. Alright, let's try it for side B now. Alright, to get B all by itself, here's that variable term we're trying to get all by itself. we have an a squared term and a c squared term. We want to get b all by itself, so the first thing you need to do is remove the a term. So we're going to subtract it from both sides of the equation, just like what we did before when we were solving for a. So that cancels out, and we have b squared is equal to c squared minus a squared. Do you see where this is going yet? So the next step, to get rid of that exponent of 2 on the b, you'd have to take the square root of both sides so that the root can cancel out the exponent. You're then left with b is equal to the square root of c squared minus a squared. Notice that that is not much different from the last equation that we just did when we were solving for a. So even though the formula a squared plus b squared equals c squared is on most standardized exams formula sheets that you're given, it doesn't solve for anything the way you see it. Therefore, I strongly recommend and encourage you to memorize not the a squared plus b squared equals c squared formula, but actually those three formulas that we just spent the time solving for, those three variables, so that you won't have to do what we just did right now in order to solve for any missing sides. So these three formulas right here, these are the three formulas to help you solve any of the three missing sides on a triangle. So next, let's look at some problems where we can actually use these three formulas. Alright, looking at problem number 1, we do see that we have a right triangle. We know that it's a right triangle because they put that little box in the corner. Otherwise, don't assume that a triangle is a right triangle without that little box in the corner, or unless you specifically see in the directions or written in the corner 90 degrees to let you know, or that the directions say that it's a right triangle. So that's important to know. Alright, the next thing you should do is label your three sides, A, B, and C. I actually would always recommend labeling your side C first. Look for that right triangle or that right angle and go directly across from it. Label that side C. After that, it really doesn't matter which you label A and B. So on side C here, and I guess I'm going to call that one A and that one B, altitude and base. Now, which side don't we know? Well, according to my labels here, I do not know what side A is equal to. Because I do not know side A, I'm going to use my side A formula. So side A is equal to the square root of C squared. Well, let's plug in the number. Instead of writing C, what do we write? 13. So you write 13 squared minus, that's from our formula, B squared. Well, instead of writing B, let's look at our number that we have there. It looks like it's 12. 12 squared. Now this is where you definitely want to get out a calculator. I don't expect you to do 13 times 13. Some of you might know it off the top of your head. I don't know. I don't. But I'll go ahead and use a calculator at this point. So after you've plugged in all your variables on that side of the equation, now we just need to evaluate it. Get it down to that single digit. You do need to follow, though, the order of operations, so we need to solve those exponents first. 13 squared, when you put it in your calculator, is 169. Minus, now find out what 12 squared is equal to. I have 144. After you solved your exponents, we haven't really talked about roots before, but whatever's underneath the root would be next, which is a subtraction problem. So you just need to subtract 169 minus 144. I get 25. and then you solve for what the square root of 25 is. Now this is a number under 100, so you should have these memorized. If not, go ahead and continue to use your calculator. The square root of 25 is 5, because 5 times 5 is 25. So that is our missing side A. A is equal to 5. Oops. That missing side is equal to 5. Okay? So you see how to use these formulas now? Let's try another one. Okay, so in problem number 2, we see that we have a right triangle. Go ahead and label your 3 sides. I'll wait. Alright, hopefully you started with side C. Did you label this side as side C? We know that that side is side C because it's directly across from your right angle. After that, it does not matter which you label A as A and B. I'm going to go this one A this time and this one B, even though our base isn't on the bottom. It's okay. And it would not matter if I flip those two around. So again, I asked myself, well, which side don't I know? Well, because I labeled this A and B where I did, I don't know side A, so actually we're going to use the exact same formula again. You want me to choose a different one to change it? Never mind. We'll just go ahead and use the same one. Alright, so if we don't know side A is equal to the square root. And again, we're going to fill in, what's our C? 13.9 squared minus our B value is 6.7 squared. Alright, now evaluate the expression. You'll have to find out what 13.9 squared is equal to first. 13.9 squared. Your squared button, if you don't remember what it looks like, it has an X with a little 2 up in the air. Almost all calculators have the same button for the squared. I got 193.21 for that. My calculator. Sorry, that writing's not right, but let me rewrite that for you. That's a little better. Alright, next I need to find out what 6.7 squared is equal to. 6.7 squared. To get 44.89. Now I need to subtract. So I take 193.21 minus 44.89. And I got 148.32. And I don't have that one memorized as far as the square root of that, and I don't expect you to do it either. So we have to use our calculator to find out what the square root of that number is. And I'm getting this really long decimal number. Now I'm going to go ahead and check my math right after I write this down and make sure I didn't make any mistakes somewhere. At 12.7, it goes on 8, 6, it's really long. 9, 8, 7, yada yada yada. Because our problem only uses one decimal spot everywhere, let's round to the the 10th spot on this. So this is about equal to 12.2. And let's look at our label. It looks like it's labeled all in miles. Oops. Dyslexic there. So 12.2 what? 12.2 miles is the distance of that missing leg of the triangle. Now, like I said, I'm going to check my math one more time to make sure I was really supposed to get those long decimals. Yes, I did the problem again. I still got the same answer. Okay. So 12.2 miles is what we're going to round that to. Alright, let's take a look at problems number 3 and 4. Notice in the problems 3 and 4, they do not give us a picture of a triangle. That's okay. What I'd recommend you do when you're not given the picture of the triangle is draw one. It's okay. So I'm going to make a right triangle. I'm going to put a little box in the corner. And I see that they gave me 11.9 is equal to side C. Side B, 4.2 is the base. I don't know what side A is. So here we go, A. Oops, I almost wrote B. That's side C. Remember, side C always is the diagonal. Side B. Alright, let's see if you can remember our 3 formulas. They spell CAB, C-A-B. Here we go. The first one is the square root. No, they all have square roots in them. The first one is the square root of a squared plus b squared. Look, CAB, C-A-B. The next two both start with a c squared. Help you remember these. They both start with a c squared. And then you have to subtract the opposite variable squared. So if we're solving for a, we would subtract b squared. If we're solving for b, we would subtract a squared. There you go. That's how you can memorize your 3 formulas. Okay, so which one are we solving for this time? Good old A again, huh? I promise you we'll have one where it's side C. Let's solve for it. So A is equal to the square root of side C squared. So which one's C? 11.9 squared. By the way, side C will always also be the longest side of the right triangle. So they just give you sides and they don't even tell you if it's A, B, or C. The longest side will always be side C. So minus the other side squared. Alright, get out your calculator and let's find out what 11.9 squared is equal to. 0.9 squared. I get 141.61 minus 4.2 squared. I get 17.64. You need to subtract those two. So 141.61 minus 17.64. I'm running out of room here. I get the square root of 123.97. So then you have to take the square root of that number. And I'm getting this great big long decimal again. Once again, because the problem has only one decimal place in both my side C and side B, we're going to round it to the tenths place. So my final answer is about 11.1 kilometers because our 2 other measurements were in kilometers, so that's side A. I want you to go ahead and try problem number 4 on your own as far as you can possibly get, and then push play and let's see how well you did. Alright, you ready to see how you did? Alright, they give us A, they give us B. What we don't know is side C. Now before I said you could draw a picture, but obviously if we have them labeled too, you could just plug that in the formula. So the side we don't know is side C. So we're going to use our C formula. Yay, we get to use a different formulas this time. So C is equal to the square root of A squared. So what's our A value? 9. So 9 squared. Plus this time, because we're using the C formula, B squared. B is 12. We need to square it. Evaluate the expression. 9 squared is equal to 81. Plus 12 squared. I believe it's 144, but let me check. 12 squared is 144. You need to add these two numbers together this time. I get 225. And then take the square root of the 225. And you should get 15. So side C is equal to 15. How'd you do? If you missed it, look back at your work, see if you used the wrong formula. If you used the right formula and still don't know what you did wrong, then please see an instructor. Now let's take what we've been learning and actually apply it to some word problems or some real-life situations. Problem number 5 reads, how far from the base of a house do you need to place a 15-foot ladder so that it exactly reaches the top of a 12-foot wall? Now what they're assuming is that you have, well, it is, when you lay a ladder up against any building, you will form a right triangle, because the building is straight up and down. So there's our right triangle. Do you see it? They want to know how far from the base of the house. So if this is our house, if this is our house right here, what they're wanting to know is this B value, the length from the side of the house to the bottom of the ladder. Let's label the other sides of this triangle. They tell us that we're using a 15-foot ladder. So where would that go on our triangle? Here's our ladder, so this would be our 15 feet. Sorry, you can't see that too well. Let me try that again. That side right there is your 15 feet. The ladder forms a diagonal up against the wall. So what letter should we label that 15 for sure? That has to be our side C, the only diagonal side. The other number that they give us is the top of the wall. They tell us that it's 12 feet. Alright, so that means that must be our side A. So what we don't know is side B. Let's see if we can remember our 3 formulas. It's good to practice writing these. So C, A, B, cab. Here's our 3 formulas. All 3 formulas have a square root sign. The first one also spells cab, C-A-B. They're squared. And this one uses addition. The rest of them start with C squared, but use subtraction. B squared and A squared. Alright, so which formula should we use? We don't know side B, so we have to use our B formula. B is equal to the square root of side C, which we said was 15, squared, minus our side A, which is the 12, squared. Alright, you have to find out what 15 squared is equal to. It's 225. I thought we did that one already. Minus 12 squared is 144. So subtract those two. And you get 81. 81 is under 100. You should have that one memorized. The square root of 81 is 9. Because this is a word problem, you should always label your answers. So look back in the story problem. What should be the label? 9 what? 9 feet. Alright, think you can do these? Let's go ahead and look at number 6. Again, we have a story problem here, and there's no picture to go along with it, so you might have to draw what you're seeing, or what you're reading about. To get from point A to point B, you must avoid walking through the pond. Okay? To avoid the pond, you must walk 34 meters south. South. Isn't that like down? 34. And 41 meters east. Do you remember your cardinal directions? North, south. If you don't remember which is east and west, it spells we, W-E. Oh, so the east goes that way. Okay. 41 meters east. This is to the nearest meter. How many meters would be saved if it were walked through the pond? Okay, so what we're saying is that, sorry, let me get another color here, is there must be this pond right here. They want to know what is the length from here to here. Well, here's our right triangle. So that length from there to there that I have in red, what label are you going to get, A, B, or C? It's a diagonal line, so this is side C. We don't know our side C. Again, it doesn't matter how you label the other two. I call this side B and this one side A. A for altitude. Altitude is just another word for height. And B for base. Right? So now we need to think back about our 3 formulas so that we know which one to use. Remember C, A, B? Now I'm going to stop because I know we need side C. So once I get the first one down, I'm not going to worry about the other two. This C is equal to the square root of, oh, this is the one that also spells cab. And this is the one I have to add. Add cab. Doesn't really rhyme. I was trying to find some way to help you remember it. Okay. Let's plug in the numbers we're given. C is equal to the square root of A squared. A is 34. So 34 squared plus B squared. B is 41, so we have to square that. Find out what 34 squared is equal to. I have 1,156 plus 41 squared. I got 1,684. Add those two numbers together. What did you get? I got 2,837. And then take the square root of that number. And I get a big long decimal, but look what it says here in the directions. To the nearest meter. These are all in meters. The nearest meter would be the nearest whole number. I have 53.2634, yada, yada, yada. 53 is what it rounds to. So 53 what? Meters. The last two questions are pretty interesting. They give us 3 sides, A, B, and C, and they want to know, are these right triangles? Well, in order for them to be right triangles, they must satisfy a formula of A squared plus B squared equals C squared. So, how would you go about doing this? Well, the first thing you would do is label side C. Remember I told you that side C is always your longest side? So that would be side C. And then the other two sides, it does not matter which you label A and which you label B. But C has to be the longest side. Alright, so to make it easier on ourselves, let's do our cab here. A, B squared, squared, plus What we can do to try to figure out if this is a right triangle is if we plugged in our A value and our B value into this equation, we should get 15 as an answer. That's the only way that this would make it work. That it'd make it work in order to be a right triangle. If we get something different, then this can't be a right triangle. So I have to find out what A squared is, or 9 squared plus 12 squared. Well, 9 squared is 81 plus 12 squared is 144. Add those two together. Plus 144. I get the square root of 225. Take the square root of that value, and I get 15. So that's correct. 15 is 15. So yes, number 7 is a right triangle. Let's check number 8. So looking at number 8, which is our longest side? The 13 is our longest side, so that has to be side C. So let's just go ahead and label the other two as A and B. Do the same thing again. Replace your A and your B with the numbers that you're given. So 7 squared plus 12 squared. 7 squared equals 49 plus 12 squared is 144. Add those two together. Get the square root of 49 plus 144. I get 193. And you take the square root of that. And I get some really big long decimal, 13.89, whatever. Now this has to be exact for it to be a right triangle, because they said that C was equal to 13, not 13.89. Because those do not match, then no, number 8 is not a right triangle. Okay, so you're going to have some practice problems to do on your own, and the answers are right along with them. Please check your work right after you're done to see if you're getting them right, and then there's a short homework. There is no Unit 7 test, but these questions will appear on the application part of the TABE exam, which you'll have in another day.